Welcome to your Unit 2, Permutations and Combinations. 2.2, what is a combination? Notes. Woo, exciting. All right, what is a combination? A combination are the number of ways of selecting R items out of N items. Repetitions are not allowed. Okay, not allowed. Order is not important. So, repetitions are not allowed. Order is not important. When we're looking at combinations, we're looking at subsets of N items taken R at a time. Clue words, subset, group, sample, selection, committee. These are all words that you might hear in our problems that we're working on. Here is your formula. So N are our objects we have. C stands for combination. R is how many spots we have to fill or how many objects we're taking. So the formula, I'm going to write it kind of big up here. N factorial, R factorial, N minus R factorial. And I know right now you're saying, hey, Miss Parrott, this looks really familiar to permutations. It is, okay? So they both do not allow repetition. However, where they're different is that the combinations have this extra R right here. Okay, so for example, I have 8 people, and I'm going to choose 3 of them to come to California with me. I can only fit 4 total people in my car, okay? So 8 people, I only have 3 that I can take with me to Cali that I'm going to choose from. 8C3, it doesn't matter which 3, okay, because whether I pick them, whatever order I pick them, they're still coming with me, okay? So N factorial on top. And then on bottom, I have my R, 3 factorial, 8 minus 3 factorial. Do what's inside your parentheses first. So on top, 8, 7, 6, 5, 4, 3, 2, 1. All over, 3, 2, 1. 5, 4, 3, 2, 1. I got the 5 factorial. 8 minus 3 is 5 factorial. Notice that these cancel on top and bottom. On top, I have 8 times 7 times 6 over 3 times 2. Okay, so 3 times 2 on bottom gives me 6. I multiply this out on top. When I'm done, I'm going to get a total of 56. Okay, so there's 56 ways that I can choose 3 people to go with me to Cali. Okay, I know that was a little fast, so if you need to pause the video, take a second, comprehend what we're going over, and then you can always come back and follow up. So, a common form of poker involves hands or sets of 5 cards each dealt from a 52 cards. How many different 5-card hands are possible? So when you're dealing, it doesn't matter which one you give them first. They're still going to end up with it in their hand. So 52, C5, I'm using my formula. NCR equals N factorial R factorial N minus R factorial. So I'm getting 52 factorial on top, R, and then 52 minus 5 on bottom. So 52 factorial, 5 factorial, and 47 factorial. 52, 51, 50, 49, 48, 47 factorial over 5 factorial, 47 factorial. Notice the 47s are going to cancel. 5 factorial is 120 on bottom, and then I just have the stuff on top to multiply out. So let's see, we get 52 times 51 times 50 times 49 times 48. I get 311,873,200. Dividing that by 120. Let's see, it was 2,598,960. And this guy right here, 311,875,200. It's a big number. Okay, so this is what I'm left with. Okay, so there's how many possible hands you can be dealt. So when they're talking about your odds and playing poker, and you're going to make so much money when you're betting on poker, Oh, yikes, do the math behind it. It's a little scary. Okay, find the number of different subsets of size 3 in Math Rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9 options. 9, C, 3, 9 factorial, 3 factorial, 9 minus 3 factorial. 9, 8, 7, 6, 3, 2, 1. These cancel. I'm left with, let's see, without having to use calculator, this simplifies to 3, 4, so 12 times 7, I think that's 84. You guys are killing me on my mental math today. 12 times 7, 84, yeah. Okay, so if you followed what I just did there, I took what was on bottom, 3 times 2, and I knew, because we're doing division, I can divide out pieces. So I know 9 can be divided by 3, and that gives me a 3. 8 can be divided by 2, it gives me a 4. So instead of multiplying 9 times 8 times 7 and then dividing by 6, I can just simplify a little bit ahead of time, and I end up with 84 is my answer. If that does not make sense to you, don't do it that way, okay? That's just a way for me to simplify so that I'm not constantly using my calculator. 11 students put their names on slips of paper inside a box. 3 names are going to be taken out. I feel like we're on a roll with 3 today. Let's do 4. So 11, C, 4, 11 factorial on top, 4 factorial, 11 minus 4 factorial. So 11, 10, 9, 8, 7, 4, 3, 2, 1. 7 factorial, these cancel, woohoo. 4 times 2 is 8, 3 goes into 9 3 times, 11 times 3 is 33, times 10 is 330. Okay, so again, you don't have to do it this way, you don't have to simplify the way I'm simplifying. You can multiply everything out and that will give you the exact same answer. Okay, last problem. Over the weekend, your family's going on vacation, and your mom is letting you bring your favorite video game console as well as 5 of your games out of 12 total. So 12, doesn't matter which 5 you're bringing, you get to bring 5. Okay, so 12 C5, 12 factorial, 7 factorial, 5 factorial. Okay, 12 minus 5 is 7. So 12, 11, 10, 9, 8, 7 over 5, 4, 3, 2, 1 times 7 factorial. These cancel, and I know 5 times 4 times 3 times 2 times 1 is 120, which is 12 times 10. And I'm left with 11 times 9 times 8, 792. Easy. You'd be there all week just deciding which games you're going to bring. Okay, that was it for notes. Wow, I went really fast. I'm sorry about that. But it's really good information. It's kind of fun when you get down to it and you start recognizing patterns and getting to simplify. There are tons of YouTube videos about this too, so if you need further help, go ahead and search them out. And this is also on your calculator. The NCR is in your calculator. So if you want to know how to do it in a calculator, you are more than welcome to do that. Go ahead. Okay? All right, guys. Have a great day, and I will talk to you soon. Thanks.